We're going to take a look at some more of these conditional statements. Now, we've looked at things before, if P then Q. That's just the form. We care less what P and Q is, and we know that the converse is if we switch those around. So, let's try this. If Sylvester walks to work, then it is a Wednesday. Okay? So what's the hypothesis? No. What's the hypothesis? Okay. If Sylvester walks to work, that's the hypothesis, correct? It's always what precedes the if. And the conclusion is going to be what? Okay. Now, can I switch this around? So if I take a look at the converse, that means is if it is, if it's a Wednesday, then okay. So if the original statement is true, is the converse true? Okay. Because if he walks to work, then it's Wednesday, right? And if we see it walking to work, it should be a Wednesday, correct? So, okay, we can live with that. Well, I don't know. If the original statement is true, they gave us that assumption to begin with. So they told us that it had to be true to begin with. Okay. So if that is a true statement, yeah. Otherwise, if I see Sylvester walking to work, it doesn't necessarily mean it's a Wednesday, does it? We don't look for exceptions to the rule. We look at what it says and go from there. If Sylvester walks to work, then it is a Wednesday. Now, does Sylvester walking to work cause it to be a Wednesday? It's a Wednesday after Tuesday, regardless of how you do things, right? It's just the way it's going to be. Okay. So, now, a negation is not. Got that little tilde thing in there, okay? For example, the negation of a pentagon is regular is pentagon is not regular. It's just putting the not in front of it. It's the yes or no thing. Okay? It either is or it is not. So, if a pentagon is regular, then it is equiangular. Okay? What is the hypothesis? Nope. Nope. Oh yeah, that's hypothesis, yes. But what is the hypothesis? Not quite. You got too much stuff there. No, you got too much stuff there. Is regular. Okay. If something is regular, then the conclusion is that it is equiangular, correct? So, I want to do the negation here. So we're supposed to write the negation of each if the pentagon is regular. So if I want the hypothesis, that means it would be is not regular. It is not equiangular. Now, I haven't even begun thinking about whether this stuff is true or not. I just simply want to identify how it's going to be written. Okay? Now, the reason why the Pentagon wasn't going to be put in there, that's what we're talking about. We're talking about that Pentagon. Because that Pentagon, it's almost like the hypothesis is going to be is going to be the adverb, adjective, description, as opposed to the action or the noun. So we're talking about a pentagon. A pentagon is regular. Okay, that's the hypothesis. Now, could I have a square as regular? Could I have a triangle as regular? Could I have some object as regular? Okay, that's why we don't want to add the pentagon part of it. Okay? So, think about this. Inverse. Now, the inverse of a conditional statement is formed when its hypothesis and conclusions are both negated. So, if P, then Q is, if not P, then not Q. The converse of the conditional and the inverse of the conditional of the same conditional statement always have the same truth value. Either they're both true or they're both false. Okay? They are called logically equivalent statements because they both have the same outcome. So, let's look at this. It says, for two lines that are cut by a transversal, if alternate interior angles are congruent, then the lines are parallel. Okay? So, first thing I want to do is, what is the hypothesis? What's the hypothesis? Okay, so we got these angles right here. Basically, alternate interior angles are congruent. So what would be the hypothesis? Correction. Conclusion. Okay. So now, they want us to do the inverse of it. So the inverse is going to make us go and flip it around. Now, I'm not going to write this part of it down. I'm just going to concern myself with the if thing. So, if alternate interior angles are not congruent, then the lines are not parallel. So, first offhand, is this original statement true? If I have two lines that are cut by a transversal, if alternate interior angles are congruent, then the lines are parallel. This is true. Okay. Is the inverse true? If the interior angles, if the alternate interior angles are not congruent, so the alternate interior angles are different, then the lines are not parallel. Is this true? Yes, it is. Now, this I expect you to have written down into your little book, so I'm going to take a little time here and I'm going to let you get this written down. All right, now that you got that down, one of the things that's added in is the contrapositive. Now we know this idea, if P then Q. We know the converse, if Q then P. We've taken a look at the inverse, if it's not P then not Q. And the contrapositive is doing both of them, not Q then P. So, okay. If Maya finishes school at 1 p.m., then it is a Thursday, sorry. If Maya finishes school at 1 p.m., then it's a Thursday. So, the hypothesis would have to be finishes school at 1, correct? The conclusion is it is a Thursday. So now, if I want contrapositive, I have to flip them around as well as negate them. So, if it is not Thursday, then Maya are we through now? Okay. Does not finish school, oops, CH, at 1 p.m. Okay. So, is that true? Well, okay, if we accept that it's true that if Maya finishes school at 1 p.m., then it is Thursday. If we know that is fact. So if it's not Thursday, if it is not Thursday, then Maya does not finish at 1 p.m. Well, that's if it isn't, then it's not a Thursday. But could she finish at 1 p.m. on a Friday? So this is not necessarily true. I just know that if it's not Thursday, she's not going to be finishing school at 1 p.m. I don't have any other information about other times. So, what I want you to do is I'm going to give you a minute or so here, and I want you to do A and B. See what you can come up with. Well, that's just underneath it. It just didn't come through there. Okay, do it one more time. Ready now? Well, we're going to continue on anyhow and see if what you've got matches up. Upgrade, sir. Oh, oh, I'm on the wrong class. I'm not even on the right class. Sorry about that. Let's try that again. There we go. So, Jacob, What is the hypothesis on this statement? Okay. And the conclusion is, okay. So, what's its converse going to be? Well, we would say if a polygon is convex, then it is regular. Now, is the converse true? Can I come up with a polygon that is convex and not regular? Yes, very easily. Now, all regular polygons will be convex, but not all convex polygons will be regular. So, let's give this a whirl. Give me another couple of minutes. Let's think about this one. Negation. Not. Think negative. Not. Negation. Not negation. I assume from all the chatter that you've got it figured out. Okay, well, let's see if you're lucky enough to be able to answer. Cool. So, Colton, what's the hypothesis? Buys juice. What's the conclusion? Buys pretzels. So, what is the negation of he buys juice? So, does not buy juice. Sorry. Does not buy pretzels. That's all the negation is. Yeah, just okay. So let's try this. Okay. There you go. Give that a try. Maybe your hands should be on the pencil writing instead. Yes. Right. Yes, no, true, false. All right, so so if now I'm supposed to write the inverse, and the inverse does what again? Yeah, what does the inverse do for us? Okay, so if the lines are not parallel, then same side interior angles are not congruent. So, got that? Let's try this. Tristan, is the statement true? The original statement, is it true? The original statement, is it true? What do you have written down? Okay, so you say that the original statement is false. Oh, the original statement you're saying is true. Ah, so if lines are parallel, then the same side interior angles are congruent? And that would have to be false, because the same side interior angles add up to what? 180. So this is supposed to be false. Okay. Is the inverse true? So, lines are not parallel. Are the same side interior angles not congruent? Would that be true? Always? Could it be possible that the angles would be the same? It's a possibility. Yes. Well, no, if it was 90 and 90, then they would have to be parallel because they're 90-degree angles. But what happens if they were at 60-degree angles? Same side interior angles, both 60 degrees. You would have two lines cut by a transversal, kind of make a triangle out of it, but they would be congruent. So this would have to be false as well, because I can find a reason that says no, they wouldn't be. Okay? I'm going to give you a couple more minutes, and I want you to figure this one out. Yes, do both. Here we go. Now, what is the contrapositive of that statement? If the sum of what measures? Okay, so I got to make sure that I put that in there. Well, sometimes the English doesn't come through nicely on this. So if the sum of two angles does not what? Then what? Is that true? What does it take for something to be complementary? Most definitely it's true because two angles that add up to a 90 are complementary. Complementary adds up to 90 degrees. So if it doesn't measure 90 degrees, then they are not complementary. Okay, now we're supposed to determine the converse of the solution. Okay, no. So the converse turns out to be what? Aaliyah, what's the converse? Right, now what's what? If the sum of two angles, what? Okay. Okay. So, is that true? Okay. Now, if we take a look at these two, we've got contrapositive and the converse. Basically, the converse is the contrapositive is the negation of the converse. So, you guys got your assignment and you can get to work.